So, welcome to this edition of Seen and Solved, presented by Hubbard-Hall. I'm Tim Pennington, editor in chief of finishingandcoating.com, and have the pleasure again of joining Connor Callais, an application specialist at Hubbard-Hall, who have many different specialties that you have there, a specialist, but you cover a lot of different areas. And when you go into a shop, and one of the things I want to do today is kind of talk to you about some of the most recent places you've been, what you saw and what you solved. How's that sound?
Absolutely. Let's get into it.
I'm Tim Pennington, and you're listening to Seen and Solved, brought to you by Hubbard-Hall. Better results, less chemistry. Yes, I know. And I know your car engine is idling. You're about to go out to put your cape on and solve another problem in another state, as you normally do. You're the hero of that. So, as I said, it sounds like you kind of go into a lot of places where they're having issues, right?
Mm-hmm.
And they're asking you to sort of solve this, fix it. We don't know what's going on, and you're kind of on the clock now to kind of fix it, which I think to a higher percentage you can pretty much solve it, can't you?
Yeah, that's at least the goal when we go into place. We want to make sure that we can provide solutions that are realistic, but also going to be impactful to any applications and results.
Right. And like you said, I'm sure it's an easy fix sometimes, a big fix a few times, but let's go through a couple. I've asked you to prepare for this talk of kind of taking me out into the field. What were you asked to do? How you went about it, and what was the result? So let's talk. Give me your first example of what something you want to talk about of how you sort of rectified a situation that a finisher was having.
Sure. One of my, I'd say my first big success out in the field was we were working with a longtime customer of ours that had a basically an immersion pretreatment system where they would basically do cleaning and modification of the surfaces prior to going into a painting application. And they were expanding. So they were moving a line that had been around since the early 90s. It had been, I don't want to say neglected, but some improvements could be made there. So they built a new building and basically had a brand new line installed. And kind of during the course of this transition into the new facility, they wanted to make sure that this process was not just going to mimic what they were doing before, but how could they make this process more future-proof and address issues that they've seen over the years and kind of just be a good example going forward, so that way they can minimize their issues going into the future. One thing that kind of changed within the incoming of the parts was the supplier of the parts that they had before. They do tubes, metal draw tubes, and this process for parts that have been going through brazing application, they actually have they had a change in the type of lubricant that they had on the surface of the part.
Right. That I hear that a lot, and they're not often told.
No.
Right.
Once you start getting quality issues, then you just have to start asking questions and figure out what's going on. Yeah. So the cleaner that they had been using forever was no longer effective in removing this type of material prior to, so they started getting all sorts of quality issues. So we really had to look at the cleaner and what we could change in it and how it was being used in order to make sure that these parts are actually clean prior to going to their phosphating. So we ended up working with them, identifying what sort of lubricant we were trying to remove, and it was a stearate-based product. So we switched to a really heavy-duty caustic cleaner, and we ran it very close to boiling. We had it, I think we run it around 195 to 200 degrees Fahrenheit. And that temperature, concentration, and just overall immersion time really helps to kind of now remove that lubricant from the surface of the parts. And these, some of these parts are 8 feet long tubes, so they can, I mean, it's well up in there too. So they have to really kind of make sure that they're processing them in a certain way that they can fully remove it, not just from the external aspect, but also from the internal areas of the component as well. Another issue we saw as we incorporated a conditioner, a phosphate conditioner, or a pre-step prior to the iron phosphate. And this really helps remove, since these are coming from a brazing operation, we use this activation step to really remove any of the surface scale that's going to be on the surface of the part. So that way we really have a bare metal component. We don't have any organic or inorganic materials on the surface. And this conditioner actually has an inhibitor in it, since it is a hot acidic solution. After a part were to come out of there, it was very prone to flash rusting in a matter of seconds, really.
Really? Wow.
Yeah, especially once that inhibitor becomes depleted, we needed a way for them to be able to determine, okay, we need to know when this product needs to be basically discharged and recharged again with a new product, because once that inhibitor is depleted, the quality issues just really started ramping up. So we were able to do basically an indirect measurement of essentially the total dissolved iron in the solution. We came up with a procedure that they could check on a weekly basis to kind of indirectly measure, all right, where's our inhibitor level? Once it reaches a certain level of dissolved iron, we know that our inhibitor has been depleted. And they've been using that sort of procedure for about 18 months to 2 years now. And they said it's like clockwork. Every 8 weeks after a new bath is charged up, the inhibitor is depleted, it's time to recharge again with fresh solution. And so that was really interesting to kind of see how consistently that parameter was good at targeting, basically, is this product still fresh or not?
You talked about it was the part manufacturer had a change in the lubricant or whatever it is. Do you find a lot of people have that communication with their part customers of having them tell them when things are changed, or do they, how did you find out that it was the lubricant that was the culprit in this situation?
Well, I will say the good suppliers tend to tell their users when there's been a change. I think a lot of suppliers they're weary of giving indications of a change because they worry for any sort of change can potentially impact the customer's future intended use or applications that they're going to be doing with this part. So yes, whenever a change is made, it's best to notify the end user that, hey, this change is going to be coming and we need to make sure that we can adapt to it. When we had this change with this customer, we had to kind of do a little bit of compare and contrast. We had some existing parts from a previous prior to the change, and then we compared them with some parts after the change. And it really kind of took a good bit of work in our lab to really kind of determine, all right, what's different here? We had to do some analysis on the actual lubricant itself. Then we had to do some lab testing to determine, okay, well, we need to find what cleaner can we use that will remove these sorts of contaminants, and how do we need to use these cleaners in order to effectively target it so that it can be removed every time.
Right. So you said this was sent back to your lab to be looked at? Is that?
Yep. Yeah, we got a variety of sample parts, brought them into the lab, and kind of did some analysis on them just to determine what we needed to do going forward to make sure that this didn't create an issue for her process.
Gotcha. Okay. Good. Okay. And you said the summation was, besides them knowing exactly when that the bath had been spent, well, what other solutions that came out of that then with them?
So we actually suggested we implemented a 2-phase cleaning system. So they would go into basically an initial cleaning. They were identical in terms of chemistry and parameters used for the cleaner tanks. But the first one was kind of designed to remove the bulk of the material, and it was kind of be like the coarse cleaning or the gross cleaning, where you're going to really try to remove the bulk of the contaminants and let that solution get soiled and saturated first. Then they would go into the secondary cleaning, which was kind of a finishing cleaner, where they would just make sure that you got the majority of it off. Now let's just make sure we have it entirely clean prior to going into our rinse steps. And that kind of worked out really well, because once the first tank becomes saturated and spent essentially, well, you can drain that one off and then just move your finishing or your secondary cleaner into that first step and use it there, and then charge the second tank with a fresh chemistry in order to make sure that you're getting a consistent clean every time.
Gotcha. Great. Okay. Well, great. Happily ever after. Okay. That was interesting.
So some projects that we've been working on recently have been some vibratory projects, and vibratory is another kind of large umbrella that has a lot of different facets underneath. Generally, any sort of vibratory application, you're using mechanical action in conjunction with a chemical component to do some sort of modification to a part. You can be either deburring, which basically just removes fine metal from the edges and the surfaces of the parts, or you can do like a polishing using a media that can lightly polish the surface of the part, or you can even do what's referred to as accelerated mass finishing, where you're using a chemistry to refine the surface and smooth out the actual surface of the part. All of these processes require several different inputs that you have to take into consideration in order to achieve the right finish or the desired look that you're trying to get. So we've been working with a couple of different companies, as we've seen. I mean, the price of any sort of phosphate products just kind of gone up through the roof. So people are looking for different alternatives for how they can still keep these processes in place, but not turn them into money pits, basically having to dump all these chemistries down the drain. So work with a couple of different people on identifying some effective phosphate chemistries that they could use in these processes. And oftentimes we can identify their existing product, find our offset equivalent of it. Let's go ahead and use it as it was being used. And then from there, we'll try to refine their usage of it so that they can minimize their chemical use going forward and save the money on both ends.
Right.
One thing that is kind of unique to the vibratory industry in general is a lot of times these are single-use products. You put it in, even if it's at a lower concentration, you put it into either your tunnel or your vibratory tub. It's used and it just goes down the drain. Well, how can we minimize that amount that we're actually having to put down the drain?
So why is it being changed out? Is it because the next part coming in may not need that, or?
Yeah. So with accelerated mass finishing in particular, it's kind of a active process where you're actually depleting the chemistry. It's being actively consumed. So you really only put in a certain amount for a certain volume or a certain surface area of working material. So once you dose it in, once it's been processed, that chemistry is effectively dead. So we can minimize that use by either dialing down the amount of chemistry I'm going to put in and monitoring to see what sort of influences that has on the active process. Or when it comes to maybe a burnishing step, we can see what is our absolute minimum concentration that we can run at, rather than running at 1% to 2%, maybe 0.5% would be effective for them. So kind of looking at a bunch of different factors to try to see where we can.
You know, it's so funny, Connor, the word audit in finishing is such a negative connotation, right? People talk about NADCAP audits and ISO audits and all of these, right? But it sounds like a lot of what you all are doing when you're asked to come in and kind of look at something that, like I said, they're expanding or they're adding a new line or whatever it is. But it seems like the end result of a lot of these audits, not that you all are doing an audit, but you're coming in and putting eyes on it, which is really truly an audit. I mean, it does seem like it results in better efficiencies, right? You usually catch something where people are dumping way too soon, and you're saving them money that way. And then also, like I said, just getting the parts faster through a system so they can coat more parts, right? So it seems like, but like I said, that audit sort of has a negative connotation, but it seems something that shops should be very actively doing, of bringing somebody in to saying, go head to toe and look at what we're doing. Tell us what you think.
Yeah. And I'll say anytime we go in and do an audit or look at a process and work through with an applicator, their steps throughout this application, the biggest question we ask is why? Why are you doing it this way? And not that everything is wrong with what they're doing, but just trying to get to the root of, all right, why are they dumping their baths so frequently? All right, well, what's causing them to have to dump these baths? What's changing? Are we having contamination? Are we having the chemistry just being used up too quickly? Are we having quality issues? I mean, everything kind of stems back to why. And from there, we can kind of go in and troubleshoot more effectively. Because once you get a full holistic picture, you can then start to look at different places. All right, where can we make minor changes that are going to have a big impact?
Right. And again, it's all two things. Bottom line, reducing rejects, right? And also saving money. And I think it's funny is that, rejects, people can see those, right? They see those, they know they got to go back and fix the line. but becoming more efficient, not having to dump. It's probably something they're probably not even aware of a lot of times, that they, like you asked, why are you doing it? And I'm sure the answer is, well, we've always sort of done it that way. That's just the way we've always done it. And I'm sure, when you can kind of reduce the amount of dumpage and you can let things become longer lasting, I think, first of all, they're happy. I'm got to be very happy about that. And then, but it is hard, like I said, for people. They don't want to change a lot of what they've been doing because it's worked very well for them. They're slammed, like you said. They're just trying to get parts through as best they can at the highest quality. And sometimes it is very good to take a step back and look at things. It is definitely the solving part of Seen and Solved. So, Connor, appreciate it. Again, thank you for joining us.
Thank you very much, Tim. Pleasure.
Seen and Solved is brought to you by Hubbard-Hall. Better results, less chemistry. For more podcasts, go to hubbardhall.com or wherever you get your podcasts.